Hey guys, what we'll be talking about in this video is the mass formula. And this is a super important formula. I use this nearly every single day that I'm at work. Um, you'll be using anytime you see concentration in milligrams per liter, pounds per day. Whenever you see pounds per day, you will always be using, actually this mass formula. If you're dealing with flow like million gallons per day, you will be using this loading rate formula. If you have an older form of this sheet, it'll likely call this loading rate formula mass flux. That's what it used to be called, but it's essentially the exact same formula. The loading rate uses flow or million gallons per day, while mass uses volume in million gallons. But it's essentially the exact same formula. That's why I don't like that they changed it to loading rate, because that can be easily confused with hydraulic loading rate, which is completely different. Um, but the loading rate and the mass is essentially the same formula, just one's dealing with still water, the other one is dealing with flow. So what you'll use this mass formula for is stuff like chemical dosage, BOD, loading, removal, pounds under solids, pounds of solids under aeration, and even the WAS pumping rate, the WAS pumping rate. So say you want to find the pounds per day that you need of like chlorine. If your flow is 3.8 mgd, so we got a flow of 3.8 mgd, and you need your dose needs to be 2.7 milligrams per liter. We want to find out how many pounds per day we have to pump into our system. So you take that formula, that milligrams per liter times the flow, since we're using per day, mgd, we're going with flow, and then the 8.34 is the last part of that conversion. If you remember, that 8.34 is also right here. So when we're finding pounds per day, that's the number we're using, that 8.34. So if we have concentration is 2.7 times 3.8 mgd times 8.34, that'll give us our pounds per day. So that's 2.7 times 3.8 and make sure your calculator is working right. 3.8 times 2.7 times 8.34. So that gives us a flow of 85.6 pounds per day. All right, so let's say we need to know what our pounds per day the chlorinator needs to treat a flow of 2 mgd. If the chlorine demand, what we need to use is 10 milligrams per liter, and we want a chlorine residual of 2. So after we use up that 10, we want 2 left over. So this is essentially the exact same thing, but they just try to confuse you with this 2 milligrams per liter residual. And all you'll do to figure out that residual, instead of needing 10, you actually just need 12. So that's just a much easier way of saying that. We actually just need 12 milligrams per liter is how much we need at 2 mgd. Alright, so all we have to do is plug that in. We take 12 milligrams per liter times 2 mgd times 8.34, our magic conversion number. So that's 12 times 2 times 8.34, and that gives us 200 pounds per day. All right, so now now that I think we have that, let's go with let's find a concentration. So the chlorine feed right now is, we know that it's 175 pounds per day. That's how much we're using. The flow in the plant, 2,450,000. So what is the dosage? That's what we want to find, how much we're dosing right now. So we just plug it in. We got X for the milligrams per liter, X milligrams per liter, that's what we're looking for, times the formula, the mass formula requires MGD. So this 2,450,000 is 2.45 MGD. And then multiply that by 8.34. And that equals 175 pounds per day. All right, so like we've done in past videos, we want to get this X by itself, so we got to divide. We got to divide all this, 175, by 2.45 rather, by 8.34. So we have 2.45 times 8.34. That equals 20.43. You take 175 divided by 20.43. And that equals 8.6 milligrams per liter is our dose. 8.6 milligrams per liter. Alright, so we've been doing flow. Let's see if we can do some just regular mass. We'll say a storage tank has to be disinfected. It needs 50 milligrams per liter. It's the concentration that it needs to be disinfected. The tank holds 70,000 gallons. How many pounds then will we need? Alright, so we just plug in our formula. We got 50 milligrams per liter. Our mass, or our volume, 70,000, but remember we have to go to million gallons. So that's going to be 0.07 million gallons. You can just divide that by a million. Multiply that by 8.34. And that'll give us our pounds. So we got 50 times 0.07 times 8.34. That equals 29.2 pounds. That's how much chlorine we'll have to buy to disinfect that storage tank. Alright, let's see. Alright, let's do some BOD TSS. So we have to calculate the BOD loading in pounds per day on a stream if the secondary effluent flow is 2.5 MGD. The flow is 2.5 MGD. The BOD of the secondary effluent is 20 milligrams per liter. It's very high. Alright, so we just plug in our equation. We got 20 milligrams per liter times 2.5 MGD times 8.34 that equals 417 pounds per day. And that's it. It's the exact same problem we've been using all along. So don't let them confuse you or throw you off by throwing in BOD or COD or TSS or anything like that. It's the exact same mass formula. If you see pounds per day, you're going to be using, or pounds, you're going to be using the same mass formula. All right, so let's do another one. The suspended solids concentration of wastewater going into the primaries is 480 milligrams per liter. Going into the primaries. Plant flow is 3,600,000 gallons per day. So how many pounds per day is going into the primary system? Same thing we've been doing. We got 480 times, remember it has to be in million gallons, so 3.6 million gallons times 8.34. So we've got 480 times 3.6 times 8.34. That equals 14,412 pounds per day of suspended solids. That's it. Doesn't matter if it's suspended solids, BOD, chemical bleach concentration. It's that formula. Plug it in. Make sure all your factors are right. If it's gallons per day, make sure you put it in a million gallons or million gallons per day. But that's it. Let's see. Same with removing or adding. It's the same formula every time. And I can show you that. So we say we have TSS being removed from a primary clarifier. Flow to the primary clarifier, 2.7 mgd. The influent going into the clarifier is concentration of 230 milligrams per liter. Primary effluent is 110 milligrams per liter. So we want to know how much is being removed inside the primary. The influent is 230. The effluent is 110. All right, so we just calculate this out. If we want to know what's being removed, we just take the influent, 230, minus the effluent is 110, which equals 120. So if the influent is 230, the effluent is 110, then we know that 120 milligrams per liter is being removed. That's simple. So we use the same mass formula we've been using. 120 times 2.7 times 8.34. Multiply that out. We get 2,702 pounds per day removed. You can do that with pounds removed or BOD removed. It works for all of it. All right, so now we're going to find out how many solids we have currently in the aeration basin. This is something that's important to know. This is something that I do quite often. It's very important to know. So, say you have your aeration tank volume is 450,000 gallons. The way you'll find how many pounds, the way you'll find the concentration is by looking at your MLSS number, your mixed liquor suspended solids. So in this case, our suspended solids are 1,820 milligrams per liter. So we want to know how many pounds of solids are in the aeration basin. Same formula we've been using, because we're looking for pounds, or whenever you're looking for pounds or pounds per day, it's always the same formula we've been using, the mass formula. So we have 1,820. Remember, you gotta have have it in mgd or million gallons, so that's 0.45 million gallons times 8.34. Multiply that out. £6,830 pounds of MLSS currently in the aeration basin. All right, we're going to switch this up only a little bit. We're still going to use the same mass formula we've been using over and over and over again. But this time, our suspended solids concentration is going to be 2,300 milligrams per liter. And instead of just giving us how much the aeration tank holds, we're going to say that the basin is 110 foot long by 35 foot wide by 13 foot deep. All right, so how do we figure this out? Well, first we just have to get it to million gallons because that's what the formula requires. So in order to find the volume of this, we have to go back to the very first video. How do we find the volume? Length times width times height. So the volume, 110 times 35 times 13. So our volume, that's cubic foot times 7.48. Don't forget the conversion. I almost forgot it. 374,374 gallons of water. So remember that 7.48 gallons is how many gallons are in a cubic, or how many cubic feet are in a gallon, or 7.48 gallons in 1 cubic foot. So you don't forget that conversion factor when you're going to gallons from cubic foot. Remember, this gives you cubic foot. All right, so again, we need this in million gallons for our formula. So you just divide it by a million, and that just gives you 0.37 million gallons. So now you just plug in the same formula we've been using, 2,300 milligrams per liter times 0.37 million gallons times 8.34. And that gives us 7,097 pounds MLVSS. All right. Last thing we're going to do in this video is the WAS pumping rate. All right, so the wasting suspended solids concentration is 5,860 milligrams per liter. If we want to waste 3,800 pounds per day, what must the wasting pump rate be in gallons per minute? So we're looking for the gallons per minute. All right, so we're actually looking for the flow here. So we plug in our formula, 5,860 milligrams per liter times X MGD, because the formula still, even though we're just using gallons per minute, the formula requires MGD, so we have to find the MGD, times 8.34. And that equals 3,800 pounds per day, because that is how much we want to waste. That's what we want our flow to be, or that's how many pounds we want our flow to be. That's how many pounds we have. So we need to know what our flow needs to be in order to get to that. All right, so like we've done previously, to get this by itself, we divide across the equal sign. So 3,800 divided by 5,860 times 8.34. So 5,860 times 8.34. That equals 48,872. So 3,800 divided by 4,872. We're at 0.07 mgd. All right, the original question though asked for gallons per minute. So we have to go to, actually, all we have to do is multiply it by 1,000,000 to get 70,000 gallons per day. Now we can use this, and if we're at 70,000 gallons per day, we have to multiply by, or no, excuse me, we have to divide by 1440 to get to gallons per minute, because that's what we originally asked for. So you take our 70,000 gallons per day, divide by 1440. That equals 49 gallons per minute is what our wasting rate should be. All right, let's do that one more time. That was a little sketchy. All right, so we need 4,700 pounds per day of solids to be removed from the secondary system. The wasting concentration, 7,340 milligrams per liter. So what do we need the wasting pumping rate to be in GPM? What do we need to set our wasting at? All right, so let's write out a formula. We've got 7,340 times XMGD, because that's what we're looking for, times 8.34. That equals 4,700 pounds per day. All right, so we divide across the equal sign, 4,700 divided by 7,340 times 8.34. 7,340 times 8.34 equals 61,216. Divide that by 4,700. Which equals 0.077 mgd. So again, what we're looking for is the gallons per minute. So we have to multiply this by 1,000,000, which gives us 77,000 gallons per day. All right, and then we go back to our chart, which tells us go to gallons per day to gallons per minute to divide 1440, bigger box to the smaller box. So we're going to divide 77,000 by 1440, and that gives us 53 gallons per minute. Should be where we set our wasting rate. So that is, in a nutshell, how you use the mass formula for finding out concentration of chemical, for finding out your wasting flow rate, your pounds of aeration, pounds in the aeration basin. Yeah, that's it. Pretty simple. Just remember that formula, the concentration by million gallons by the 8.34, and you'll apply that in 1,000 different ways.